Hi guys, welcome to my YouTube channel. Guys, now we do this problem. Evaluate the integral from 0 to 1 x sine inverse x squared all over square root of 1 minus x raised to 4 dx. So guys, we do now this problem. So guys, for this problem, I'm going to do substitution. So I will say u is equals to sine inverse x squared, and so therefore we shall have sine u will now be equals to x squared. From there guys, I can now find the derivative, because guys I'm going to replace dx with du. So I find derivative for that. This is going to give us 2x dx all over du. I can write du on this other side. This is now going to give us cos u, and I write now the du on this side. From there guys, because guys I will have to replace dx, so what I have written right here is actually, this is supposed to be, is actually okay what I have written. And so guys, we now go ahead, and guys, what I will do, I will come now and write my integral here, that is 0 to 1. And guys, I can write x, as you can see here we have an x. Guys, instead of now writing sine inverse x squared, I am now going to write u there, all over square root of 1 minus x raised to 4. X squared is sine u, so x raised to 4 will be sine squared u. And then guys, I can come so that I can have something that looks like this. Remember guys, we have a dx here. We have a dx at this point. Let me just write it, dx. And then we have an x here. I can introduce a 2 here. Guys, I can introduce a 2 there. And by so doing, it will look similar to this, whereby we shall have 2x and the dx. But by introducing, I change the equation. So I'll have now to introduce another one here, a half, so that everything remains constant. So from there guys, I can come and now substitute for dx. So I have integral from 0 to 1. Instead of now writing 2x dx, guys, I will write now du cos u. I can begin with this u, which is already there, and then I write cos u and now du, like that, all over. I have already replaced now my dx. I'll now come at this point, 1 minus cos squared u. According to trigonometry, this one is cos squared u, cos squared u. The square root of cos squared u is actually cos. So we shall have a half integral of u cos u du all over the square root of now cos squared, which now gives us cos u. Guys, from there now we can cancel that cos, and we are left with the integral. I have integral from 0 to 1 of u du. So guys, we can actually do that, and that will now come to, I have integral of u is going to give us u squared all over 2. Limits, guys, I'll have now to replace these limits because you have limit from 0 to 1. But remember, these limits are according with reference to x. And so therefore I go to my where I have replaced for x, that is, we have sine u is equals to x squared. So guys, I write here sine, or guys, I can still write u equals to sine inverse x squared. So I will write here u equals to sine inverse x squared. So guys, I can now put my x to be my limits, that is from 0 to 1. So I will write u is equals to sine inverse of, I first start with 0. For 0, u is equals to be 0 also. Coming to x, that is to 1, the limit 1, we shall have u is equals to sine inverse of 1 squared, which is 1. This gives us the number that gives us the angle that gives us sine, that is gives us 1, is actually pi over 2. That is 90 degrees. And so therefore, guys, we shall have to write those limits here now. We have 0 will be 0, and we have 1 is going to be pi over 2. And so therefore, guys, our final solution then is going to be a half. We replace, for 0 it's going to be 0. For pi over 2 we shall have pi squared all over 4, again multiplied now by 2. Because this will be u squared, this is pi squared over 4, then you multiply by 2 and then by 2 yet again. So guys, finally our solution is going to be pi squared all over 2 times 2, 4 times 4. This gives us 16. And so guys, this is our solution. Thank you guys for listening to me. Bye bye.